Hello there, Mr. Sutton here with the AB Calculus 4-3 Extra Practice Number 1 Solutions on Local Extrema. On this problem, we want to know k values for which the graph of x cubed minus 3x squared plus k has three distinct x-intercepts. So this one is definitely tricky. Thinking about this a little bit, we basically need this thing to cross the x-axis 3 times, which means it has to turn around a few times. So if you're not sure how to proceed, when in doubt, take a derivative and see what happens. If we do take a derivative of this thing, we can find some critical values, and that's actually the key on this problem. We need our critical values, our turnaround spots, to give us points that are on opposite sides of the x-axis. We need to go back and forth over the x-axis. So let's take our first derivative and see what x values we have turnarounds at. So f prime then we can say is going to be 3x squared minus 6x, and then that k is a constant, so that's just going to become a 0 here. Now we want to know where this takes on a value of 0. Those are our turnaround spots, and we can factor out a 3x, leaving us with x minus 2 inside. So this is going to be true at x equals 0 and positive 2. Let me go ahead and actually make sure we have direction changes at those. So I'm going to do a number line here, some sign analysis for f prime or y prime, whatever you want to call it, between 0 and 2. Now, to the left of 0, I'm going to try a value like negative 1. And plugging this in, I see that I get a negative times a negative, which is a positive. Now let me try something between 0 and 2, like 1. That gives me a positive times a negative, which is negative. And something bigger than 2, like 3, positive gives me a positive. So I see here that I have a relative max happening at x equals 0, because f prime changed from positive to negative, and a relative min happening at x equals 2, f prime changing from negative to positive. That wasn't the question, but it's good to know that we have mins and maxes here. What we do need to do now is figure out what y value these x values give us when we plug them into the original function. So if I do f of 0, that's going to be zeroing out all these x's here, leaving us with just k. Which, I mean, we don't know what k is, but it's at least good to know that when I plug in one of my critical values, k is what I get back. Okay, so let me now plug in 2, my other critical value. That gives me back, let's see here, we've got 8 minus 12, which is negative 4, plus k. So we'll call this k minus 4. Now we said we wanted our critical values to be on opposite sides of the x-axis. These are the y values of those turnaround spots. We have k and k minus 4. For those to be on opposite sides of the x-axis so that we have to cross over in order to hit both of them, that means we need these to be opposite signs. And these are only going to have opposite signs if we're plugging in a number for k that is between 0 and 4. If you plug in something less than 0, then these are both going to be negative. If you plug in something greater than 4, these are both going to be positive. Only between 0 and 4 is this first thing going to be positive and this second thing going to be negative. So that's going to end up giving us then answer choice D. On this problem, I'm given the derivative of some function with this f prime function. It's kind of crazy. I'm glad this is a calculator problem. We want to know on this interval here, where do we have a relative max? So if I'm asking about relative maxes for f, I'm asking where does f prime change sign from positive to negative? And I'm going to figure that out by using my calculator. So here I am in my calculator in my y equals. I've inserted the f prime function as y1. And I'm going to go to window and make sure that I'm going from negative 2.5 to positive 2.5 because that's the window that they care about. Let me do zoom 0 for that. And here's what f prime looks like. So we go up and down a little bit. We cross the x-axis, cross again, cross one more time. The only place we're changing from positive to negative for f prime is this spot right here, somewhere between 0 and 1. Let me do second trace to find that exact one, and then 0 is the option here, is option 2. So let me press enter a little bit to the left, move to the right, press enter again, enter one more time. So it's at about 0.542 if I round that off. Since f prime changes positive to negative at 0.542, it follows that f has a relative max there. That answers the question. So choice E then is what we're looking for. For this problem, we're defining a function as x cubed minus 3x squared, we want to know where it has a relative max at what x value. So for that, we need to figure out where f prime changes positive to negative. F prime for this thing is going to be 3x squared minus 6x. Let's set that equal to 0 and find some critical values. So to solve this, I can take out a 3x. That leaves me with x minus 2 inside. So then my critical values are going to be x equals 0 and 2. Let me put these on a sign chart now, an f prime line, and let me go ahead and test around these with some sign analysis. If I plug in a number to f prime that's less than 0, like negative 1, that gives me a negative times a negative, which is positive. Number between 0 and 2, 1 is a good one. That gives me a positive times a negative, so negative. And then bigger than 2, let's try 3. Positive, positive, that comes out positive. So I notice here that I'm changing my f prime from positive to negative at x equals 0. Therefore, f has a relative max at x equals 0, and we pick answer choice B. On this one, we're given the function y equals 2x minus 8, and we want to know the minimum value of the product x times y. So they're asking for basically the absolute min, and they're not giving us a closed interval. So hopefully there's only one critical value so we can reason around that issue. Now let's start by actually writing out what xy looks like. I'm going to call this product f of x, and if f of x is x times y, I can rewrite this as x times 2x minus 8, because that's really what y is. And I'm going to have to take the derivative of this in order to figure out the minimum here to get some critical values. So let me just make my life easier and distribute this now. That'll be 2x squared minus 8x. So now f prime is going to be 4x minus 8. And I want to figure out where that equals 0. I want my critical values. I can add 8 and divide by 4 to get 2 for my x value on this. So we actually only do end up with one critical value. Doing a little sign analysis here for f prime, around 2. If I plug in something less than 2, like 1 or 0, either of those, that's going to give me a negative value here, just negative 8 for f prime. Something bigger than 2, like 3, well, that's going to be like 12 minus 8, which is positive. And so here's how I'm going to reason this out if this were a free response. I notice that f prime is less than 0 for x less than 2. So basically f is decreasing until I get to 2. And then f prime is greater than 0, positive for x values beyond 2. So f is increasing after we get to 2. So decreasing till we get there, increasing after. So this establishes that we have an absolute min for my xy product at x equals 2. But we haven't actually said what the min is. There's an answer choice for 2, but they didn't want the x value. When they say minimum value, they mean the y value at whatever x value gets you there. So you actually need to plug 2 back into this f function that we wrote over here. So that's going to be, probably the easiest one is just to do this squared one. So 2 times 2 squared minus 8 times 2. That's going to be 8 minus 16, which is negative 8, giving us answer choice B. For this problem, we're given f prime equals this crazy collection of binomial terms. We want to know which of the following is true about f in terms of relative extrema. So probably the easiest way to do this is just to do some sign analysis on this and then answer these questions. So I've got to set this f prime equal to 0 and find my critical values. So f prime of x, which I'm not going to bother rewriting, is going to equal 0 at whatever values zero out each of these parentheses. So at x equals 2, 3, and 4. Let me set up my f prime line now, do some sign analysis. We've got 2, 3, and 4. And I'm going to test an x value on each of these 4 intervals. So something to the left of 2, like 1, 0 would have also been pretty easy. That gives us a negative. This squared term is always going to be positive, so we're just going to ignore it from here on out. And then this cubic term is going to give us a negative. Negative, negative is a positive. And then something between 2 and 3, like 2.5, that gives us a positive times a negative, which comes out negative. Let's test out 3.5 next, between 3 and 4. So that's a positive and another negative, giving us a negative again. And finally, something bigger than 4, like 5, that's going to give us positives everywhere. So that's positive overall. So now things I notice here, f prime is changing from positive to negative at x equals 2. This establishes that f has a relative max at x equals 2. And then I also notice f prime changes from negative to positive at x equals 4, which gives us a relative min for f at x equals 4. There's no sign change at x equals 3, so there's nothing going on there. Looking at my answer choices now, option 1, relative max at x equals 2, yep, that matches what I found down here, so that's a yes. Option 2, relative min at x equals 3, well, we said there's no sign change at x equals 3, so that's a no for that one. And then finally, option 3, relative max at x equals 4. Well, we went from negative to positive f prime there, so that's actually a relative min, not a relative max. So since that's a min, that's also a no. So only option 1 was correct, which is going to be choice A. On this problem, they want to know at x equals 0, which of the following is true about this f function. So we have some options about it increasing, decreasing, relative mins and maxes. We can eliminate choice C right off the bat about this being discontinuous, because these are both, this is a polynomial which is continuous, this is a decaying exponential which is also continuous. So it's really just down to things that involve f prime. F prime on this, that's going to be 2x, and then using our chain rule, this will be negative 2e to the negative 2x. So what do we do with f prime? Well, normally we would set this equal to 0, solve for critical values, do sign analysis, but in this problem, all they cared about was the behavior at x equals 0. So why not just plug 0 into this to see what happens? If I plug 0 in for all these things, well, 2 times 0 is 0. And then this is going to be, let's see, negative 2 times e to the 0. E to the 0 is 1, so we've really just got negative 2 when the dust settles on all this. Now, the important piece of this for these answer choices is that this is less than 0. It's negative. Since it's not 0 at all or undefined, that means it can't be a min or a max. Since it's less than 0, that tells us that the function is decreasing at x equals 0. So that would be choice B. For this problem, we're defining f as ln of x over x. We want the absolute max of f. Now notice there's no closed interval here, so the candidates test is not going to work. Really, that means that we better hope there's only one critical value that we can do some sign analysis on. Otherwise, we're dead in the water on this one. So let's start in terms of critical values by taking the derivative of our function, f prime. That's going to require us to use the quotient rule. So let me bust out the box and ribbon here. I've got my numerator, ln of x, denominator was x, and their derivatives, which are 1 over x and 1. Using the ribbon to multiply all this out, I've got my fraction, and I've got 1 over x times x, which is just going to be 1, minus ln of x times 1, so minus ln of x, all over this thing squared, v squared, so that's x squared in this case. And for critical values, I want to know where this thing equals 0 or is undefined. To figure out where it equals 0, I just set the numerator equal to 0. And if I go ahead and solve this logarithmic equation real quick like, I can add ln of x over here. So I have 1 equals ln of x, and then if I just raise e to both sides, I get rid of the ln. So x then is going to equal e to the 1, or just plain old e. So that takes care of the numerator. That zeroes out the fraction. That's one critical value, e. All right, well, we also notice our denominator has some variables. F prime is going to be undefined at 0, of course, because you're dividing by 0. So that's one place. But actually, if you look back up here, ln of x also has some issues. We can't take the log of 0 or negative numbers. So it turns out f prime does not exist for all values of x that are less than or equal to 0. So that limits where we have to look on our sign analysis. Let me set up my f prime number line at this point. So this is only going to go one direction, and this is f prime now. So we're going from 0 to infinity, and along the way, we stop at this critical value of e. Let me test something in these two intervals only. So this first interval between 0 and e, a good number between those, since e is about 2.7 and some change, I'm going to go with 1. 1's pretty easy to plug in. So taking a look at my denominator, this is always going to be positive with x squared. Squaring something always makes it positive. So it's really just up to the numerator to determine the sign of this whole f prime fraction. ln of 1 is just 0. So that gives me just 1 in the numerator, which is positive. And then something bigger than e, I'll go with e squared. Hey, why not? I could go with 3, but e squared is actually easier to plug in to the ln function because I'm just getting the exponent back. So 1 minus ln of e squared is just going to be 1 minus 2, which is negative. So that means that we have a relative max at x equals e. Now to actually justify the existence of an absolute max, here's what I'm going to write. So I notice that f prime is positive between 0 and e. So f is increasing until it gets to e. And then after that, f prime is negative for x greater than e. So our function is going down after it gets to e. Well, if we're going up until we get to e and then we're going down forever after, that means we must have the max for the f function at x equals e. But that's not the answer. It's not even an answer choice, which was nice of them to not put it in there as a distractor. We actually need to plug this into the function to get the maximum value. So we're doing f of e at this point, which is ln of e over e. ln of e is 1, so this is just 1 over e, which is going to give us answer choice B. On this problem, we're given this f function, this piecewise function. We want to know which of these statements is true. So we'll just go through and eliminate what we can. Choice A, f is an odd function. So remember, in math, that means that it has symmetry about the origin. And if you look at these, x cubed and x are both odd functions. They both have symmetry about the origin. However, if you are going from negative infinity to 0 with a line, and then from 0 to positive infinity with a wavy kind of snake-shaped thing, those are not going to be symmetrical about the origin when you stick them together end to end. So this is going to be a no. All right, next option, f is discontinuous at x equals 0. Well, we need to talk about continuity here. So that means I need left, right, center, left limit, right limit on the function value. Left side limit of the f function, this is going to be plugging things into this first rule for x less than 0. So 0 cubed is 0. Right side limit is going to be just plugging things into the second rule, which also gives us 0. And the function value is the same as the left side limit, so also 0. Since our limits match up, that means the limit exists. And the limit as x approaches 0 is the same as our function value of 0. So since the limit and the function value are the same, this proves that our function is continuous at x equals 0. So that's a big no for option B. But before you think you wasted your time doing all this analysis, this next set of things here is going to require this continuity bit anyway. So these next three options, f has a relative max, f prime of 0 equals 0, f prime of x is positive. So these are all talking about f prime. So we're going to have to go ahead and take f prime of this piecewise function. So for C, D, and E, f prime. Now if you're doing a piecewise function, you can always count on being able to take the derivative of the individual rules. It's just the derivative at the border value that's a little bit up for grabs. So the first rule is going to just be 3x squared, and that's for x values that are less than 0. We can't include equals yet because we haven't actually proven that our function is differentiable at x equals 0. The second rule is just going to be 1 for that derivative, and that's for x values greater than 0. So this we can count on. This is true for sure. Now, what the derivative is at x equals 0 exactly, we shall now proceed to say. We know that this function is continuous, so that means that it could be differentiable at x equals 0. To figure that out for sure, we have to take the left and the right side limits of f prime at 0. Left side limit of f prime, we're just plugging things into this 3x squared function, which gives us 0. The right side limit of f prime, we're using our second rule now, and that's 1. Well, these don't match up, so that means that our f prime of 0 actually does not exist, which immediately eliminates answer choice D. So this does not exist at x equals 0. But it does at least give us a critical value, which would help us figure out choice C and possibly choice E. So let me graph, so this is a no for choice D. Let's just establish that. So let me graph now a number line with our one critical value of 0 on it. And this could be a max. The function's at least defined at x equals 0. So doing a little sign analysis, if I plug in something less than 0, like -1, well, that would use this first rule here. That would give us a positive if you do 3 times 1, -1 squared. And then plugging in something bigger than 0, like 1, now I'm using the second rule. That gives me a positive, namely 1. So I notice here that there is no sign change at x equals 0. So that means that we can't have a max, so answer choice C is not correct. That leaves us with answer choice D. Looking here, it looks like f prime is actually greater than 0 for all x values except for 0. So that would include, well, that would be exactly actually what answer choice E is saying, so that is going to be answer choice E that we end up picking on this one. On this problem, f is the function with a derivative given by sine of x squared plus 1. We want to know how many relative extrema f has on the interval from 2 to 4. So basically we're asking how many times does f prime change sign between 2 and 4. And this is a calculator question, so we'll use our calculator to figure out our f prime sign changes. So here I am on the calculator. I've got my f prime entered as y1. Let me go to window now, and they said between 2 and 4. So let me put in 2 and 4 for my x min and x max. Zoom 0 is going to give me the perfect window on my derivative. And it looks like we are crossing 1, 2, 3, 4 times on this one. So that means that we have 4 relative extrema, which is going to give us choice D.